In this tutorial, we're going to have a look at how we can tell the distance between two objects within a game. We're going to build a proximity sensor, just as we can see with the cop here and his radar gun, and we will show the distance using a ping as a series of concentric circles. To do this, we're going to have to use the distance formula, and the distance formula is based on Pythagoras. So Pythagoras says that if we have a right angled triangle and we know two of the lengths, then we can work out the other length. So if we know the horizontal separation of x coordinates, and that would give us our distance a here, and if we know the vertical separation between the y coordinates, and that would give us b here, then we can then square these, add them together, and then square root to find the distance between the shortest path between points A and points B, or point 1 and point 2 on this diagram. So we're going to create a Pythagoras formula that gives us the distance between any two sets of coordinates. To do this, we're going to change our core project. So this is on Birkdale Teams, and I'm going to move down here to the PyGame projects, and I'm going to have a look at number 9, customize core for own game. Now you may already have started on this and added other design features, so you'll have to adapt where the code goes to accommodate what you already have. When we load this up, it'll load up with the README file, and we should then be able to read about the different design patterns. So you'll have to use the set of slides or videos that show us how to do the proximity design pattern. So the first thing we're going to do is add some useful constants to our code. A detection radius, which will give us how wide a ping we have. We're then going to have a minimum radius and a maximum radius, and these will be used when we are showing the actual detection. And we're going to have a ping radius and a ping growth, which will determine how quickly the circles move out from the center. Much more importantly, we're going to import the math library. And the reason we're going to do that is because we're going to use math.squareroot or squirt here in order to find out the actual distance. And then we're going to build a reusable function that allows us to find the distance between any two sets of coordinates xya and xyb. So let's get started on our code then. When we go to main, I'm actually going to fork this code. You don't have to. Yours will automatically be forked when you load up the project. But I'm going to fork this code so that I don't make changes to the main version. And I need to go to main.py and begin to make some changes. Okay, so where am I going to place this? I'm going to place this, I'm going to put my new code just above the while loop. So for me that's starting at 4344 here. For you it may be different if you have other design patterns already in place. But I'm going to place my new code just above where the while loop starts. So if we have a quick reminder of what we're looking for a detection radius, a minimum and maximum radius, a ping radius, and a ping growth. So I'm going to put all in capitals, detection radius, and this has just been arbitrarily chosen to be fit in with the size of the game, so I'm going to go for 250 pixels there. Min radius is going to start off, and it seems reasonable to use the sprites, so I'm going to use size over 2, so about half of a character's width. And I can also put two things in at the same time here. So I'm going to also put comma, max radius, So I can define the two things just by putting a comma between these parts. And the max radius should probably also be equal to the detection radius. And that way it will go all the way out to the edge. Okay, when I'm doing my ping, I want a ping radius. If I can spell that with proper capitalization. So ping radius is going to start out at min radius. And I'm also going to have a ping growth. Now, this will say how quickly it changes during a frame. And from experience, I know that maybe starting with 3 is a good idea. Okay, so I've set up my constants that I'll use for this particular design pattern. I now need to declare a new function. So I'm going to say def too close. So too close is something that will allow me to see the distance between two objects. And those objects are going to have x and y coordinates. So the first one is going to be xa and ya. And the second one is going to be xb and yb. And then I'm going to be able to send in something that I think is too close. So that will be a distance. And if it's less than that distance, then we know we are too close. Because I'm defining a new function, I use a colon and press enter, and that will then indent me ready to do the code for this particular function. It's a reusable recipe that I can call over and over within the game. So if I have a look at it, I need to find out the horizontal distance and the vertical distance, and then I use Pythagoras to work out what the actual distance is going to be. So, horiz is going to be xa minus xb. Now, that could give me a negative number, and so what I've done is to wrap this inside something called abs. So that's the absolute value, which makes it positive. I'm going to do the same for vertical. So vert equals the absolute value of ya minus yb. Now, in actual fact, it's not really necessary to do this because we're going to square these numbers straight away, and any squaring would get rid of the negatives. But just to keep in with Pythagoras, I've done it this way, even though it's not as efficient as it could be. So I'm then going to say that Pythag equals math dot square root. Now, to be able to do math, I need to have the math library imported. So before my function, I'm going to say import math. And then I'm going to take the square root of horizon squared. I could use a power function here, but I'm just going to say horiz times horiz. And that's times itself, we'll square it. And then the same with the vert, vert times vert. So that's horizontal squared plus vertical squared, and then I take the square root to give me the distance. And I could just have used that directly and called it from within the program, but I want to find out if things are too close. So what I'm going to say is, if Pythag, if the distance it's worked out is less than the distance I asked it to keep an eye on, so here's a question I'm asking, if that's the case, I'm going to return 1, as in it's true. Actually, I'll just check. I'm actually going for true and false rather than 1 and 0. So I'm going to return true here. It's true that the objects are too close compared to what distance I was looking for. Now, if that's not the case, if they're not too close, then the whole function then returns false. Notice false and true with capital letters and turn blue when I'm finished typing them. If they're in black and you've got lowercase, then they won't work properly. So, I have set up some useful numbers. I have imported maths so that I can then use Pythagoras, and I've got a function which is good to go. So what can I do with this function? Well, I'm going to now check. Every time a monster is moved, I'm going to check if it's too close to our player. So this section here is going to go into the game logic part. At the moment, I've got something similar to this. I've got the monster just randomly moving all of the time. There's no question about it, it just randomly moves. Now, I want to check if they're too close. And if not, then I'll do the random movement. So the random wander here is in white, just below the yellow block. That's happening already. I'm going to make that happen only if the things aren't too close. And if they are too close, I'm going to try and move my zombies away from my cop. So, I need to go and find in my game logic. I'm just going to close up these files to give me a bit more space to breathe here. And we can see here is my for monster and NPC list. So this is the bit at the moment which is moving them a drunken walk amount of position. So what I'm going to say here is if too close, I'm going to give it the player, which is x, y, and then I'm going to give it the x and y of this monster. So that's monster 0 and monster 1. So these are the coordinates of each individual monster in the list. And what I want to say, how close would they have to be before I think it's too close? I'm going to say 2 times size. In other words, they're 2 sprites away from each other. Okay, if that's the case, then I'm going to put in a whole load of new code. But if it's not the case, that's where I'm going to put my else. Else, and then I'm just going to do what I used to do, which was a random walk. So that is putting us back where we were. It's complaining about the else here because I don't actually have any if code in. So let me go in here and say, okay, what I want to do. If they're too close, I need to know where they are compared to each other. So if monster 0 is less than x, what does that mean? That means it is to the left of the cop. And if it's to the left of the cop and it's too close, I want it to go even further left. So I'm going to say, if that's the case, then monster 0 is going to be equal to monster 0 and then minus a random amount. Now the reason I'm doing minus here, random.randint between 0 and 5. I'm using minus so that it moves me to the left. So I'm already on the left, I'm too close, I want it to move even further left. Okay, if it's not on the left of it, then I could say else, and monster 0, I'm assuming it's going to be on the right here then, monster 0 equals monster 0, and then plus random.randint. Zero to 5. So if I'm on the left, I move further left. If I'm on the right, I move further right. And then we want a similar set of code for the y direction. So if monster 1, which is our y coordinate, is less than y, that means it must be above it. So therefore I want to go further above. So I want to say monster 1 equals monster 1. Now it's above, so it's going higher, so it's minus random.randint 0 to 5. And I'm just going to copy this bit to be able to quickly do it. If it's